So this is sort of a real-world application of how these equations that we're learning to use can come in handy. So imagine that we start out with hydrated strontium chloride that we don't quite know the water content of, and that a reaction runs so that it breaks down into strontium chloride and water. We can use this information to find out the water content of our original chemical. So we're going to sort of pretend that we ran this experiment here, in that our original hydrated strontium chloride product was 2.67 grams. And then after the reaction runs and it's broken down, the strontium chloride is 1.59 grams, and the water is 1.08 grams. And so first we're going to calculate the molar mass of each of these components. And I'm not going to go step by step exactly how we do that, because you guys are probably pros at that by now after the first part of the worksheet. But I'll sort of quickly run through it with you guys. So this molar mass is essentially strontium, the molar mass of strontium plus the 2 chlorides plus the 2 hydrogens and the oxygen in water. That's how we'd get that 176.54 grams per mole right here. And then for the strontium chloride, it would be the molar mass of the strontium plus the 2 chlorides to get the 158.52 grams per mole. And then for the water, it's the 2 hydrogens and the oxygen molar mass to get the 18.02 grams per mole. So now we're going to calculate how many moles, and we're actually just going to do this for the end products because that's all we're going to need in the end, which we will get to in a second. But now we're going to calculate how many moles of our end products we have. So the way that we're going to do this is start out with our 1.59 grams of strontium chloride. Then we're going to set up our dimensional analysis so that our units cancel. So we know that our units here are grams per mole. We want the grams to cancel each other out, so we'll put our grams on the bottom. And that's grams per 1 mole. And that's going to leave us with 0.01 moles when we put that in our calculator. So now we're going to fill in our chart. So now we're going to do the same thing for the water. We're going to use what we are given in grams. Set up our dimensional analysis so that our units cancel. Make sure our units cancel and that we're left with moles. So when we plug this into our calculator, it's going to come out as 0.06 moles. And so now we are given the equation that N equals moles of water divided by the moles of strontium chloride. So we'll just go ahead and, oh, I forgot to fill in the table here. So we'll go ahead and plug that in. We have our moles of water divided by our moles of strontium chloride. And so our N is going to equal 6. And so we know that there are going to be 6 waters in that hydrated strontium chloride. And so that answers that mystery for us.